Here is the homework for pre-calc. This is section 4.6. For the first three questions, they are asking you, 4.6, they're asking you to determine if g of x is a factor of f of x without using synthetic or long division. So all you have to do is evaluate this for g of x. If x is 1, you're going to plug 1 into f of x. So you're going to do f1, and so 1 to the, that's a 10, plus 1 to the 6th power, 1 plus 1 is 2. That would be the remainder. Since you did not get a 0, no, this is not a factor. Same with number 3, you're going to plug negative 1 in here. So you have 3 times negative 1 to the 4th minus 6 times negative 1 cubed plus 2 times negative 1 minus 1. This is going to give you a positive 1, so 3. This is going to give you a negative 1, but when you, negative 6 times negative 1 is 6, so that's 9. 9 minus 2 is 7, and 7 minus 1 is 6. So no, again, this is not a factor. G of x would not be a factor of this because the remainder would be 6. And number 5 is also going to be no. You're going to plug negative 2 in here. Negative 2 cubed minus 2 times negative 2 squared plus 5 times negative 2 minus 4. And I already know that this is going to be negative 8. And this is going to be, it's going to be a positive 2. 2 times negative 2 is negative 4. Okay. And then minus 10 minus 4. And I already know the answer is going to be no. Actually, this is going to be 8. This 4 times 2 is negative 8. So negative 8, negative 16, negative 26, so negative 30 is your remainder. The next set. They're asking you to list the zeros. So the 0 for this problem, this says x to the 54th power. So you set each of these equal to 0, so 0 is your 0, and that has a multiplicity that's even. And this one is negative 4/5, and that is odd. Number 9, we have 3 zeros, x is 0, and it's to the 15th power, so that's odd. The 0 here is pi, and that's even. And then pi plus 1, and that is odd. Okay, 11 through 21, they're asking you to find all the zeros, so real and complex. So this one is not factorable, so you're going to use the quadratic formula. So it's going to be negative 2, opposite of negative 2 is 2, so it's going to be 2 plus or minus. You're going to use the quadratic because this is not factorable. Then b squared, 4 minus 4 times a times c, and then all over 2 times 1, which is 2. When you simplify this, you get 2 plus or minus, now this is going to be 20. 4 minus 20 is 16. So this is going to be 16, negative 16, and the square root of negative 16 is 4. So over 2. So your answer is 2 plus or minus 4i over 2, and then you cancel these, so 2 goes into 2 once, and 2 goes into 4 2 times, so it's 1 plus or minus 2i. Those are your 2 zeros. So how do you write? They want you to write it as a product. These are your 2 zeros. They want you to write it as a product of linear factors, so it's going to be x minus 1 plus 2i, and x minus 1 minus 2i. And that would be equal to f of x. Number 13, you're going to need the quadratic formula to do this one also. So your negative b, x is equal to negative b, so negative 2 plus or minus b squared, so 4 minus 3. 4 times 3, 4 AC, 4 times 3 times 7, all over 2 times 3, which is 6. So we're going to simplify this, and you're going to get 4 minus 84. And 4 minus 84 is negative 80, all over 6. So you end up with negative 2 plus or minus 4 root 5i, over 6. And we're going to simplify this. 2 goes into all three of these, so negative 1 plus or minus 2 root 5i over 3. These are your two zeros. So to write this in factored form as a product of linear factors, you would write, for this one, x minus negative 1 plus 2 root 5i over 3, and then x minus negative 1 minus 2 root 5i over 3. Number 15, you're going to factor this. This is going to be x minus 3, x squared plus 3x plus 9. One of your zeros is 3, and these two you'd have to use the quadratic formula to find. So it's going to be negative b, so negative 3 plus or minus b squared, 9 minus 4 times 1 times 9. So this is 36, so it's going to be negative 27 all over 2. So negative 3 plus or minus, this is going to be 3i root 3 over 2. So your answer will be x minus 3, and then x minus negative 3 plus 3i root 3 over 2, and x minus negative 3 minus 3i root 3 over 2. Next, this is x cubed plus 8, and you're going to factor this to be x plus 2, and then x squared minus 2x plus 4. This, I'm going to use the, I'm going to complete the square on this one. So I'm going to set this equal to 0, subtract 4, half, add, so it's x minus 1, quantity squared equals negative 3. So if you take the square root, so you get x minus 1 equals plus or minus root 3i, and then add 1. So in factored form, you're going to write x plus 2, and then x minus 1 plus root 3i, and x minus 1 minus root 3i. And don't forget f of x should go in front of this. Number 19, we have the difference of two perfect squares, x squared minus 1, x squared plus 1. This factors to be x minus 1, x plus 1. And then this one, I and negative I are going to be your factors, so minus I and x plus I. And that is what f of x is equal to. So your zeros would be plus or minus 1 and plus or minus I. And number 21, we can factor this, x squared minus 5 and x squared plus 2, because negative 5 times 2 is negative 10, and these add to be negative 3. So the two zeros here would be plus or minus root 5. That's what you're going to get here. And these two will be plus or minus root 2i. So in factored form, you would write f of x equals x minus root 5, x plus root 5, x minus root 2i, and obviously x plus root 2i. I'm off the side. Okay, the next three are asking for you to find a polynomial with a certain degree. This one has degree of 3, and I want the zeros to be 1, 5, and negative 4. So it would be f of x equals x minus 1, x minus 7, x plus 4. And since it says a polynomial, you can put any number in front for a. We're just going to leave it as a 1. The next one, it says I want the degree to be 6, and my zeros are going to be 1, so x minus 1, x minus 2, and x minus pi. Now, it doesn't tell you if it crosses or bounces, so you can put 2's in all three of at all three of these zeros, or you could even change this, make that a 4, and keep these as 1's, but that would be good enough. And this one, you've got zeros at negative 3, 0, and 4. So I'm going to start above because there's something we have to do. So 0 is 1, x plus 3, and x minus 4. Now what you have to do is figure out the a value because they give you a specific x and y value. So in front here, we have a specific a value we have to find. We're going to plug 80 here. 80 equals a times x is going to be 5. So 5 times, and then 5 plus 3 is 8, and then 5 minus 4 is 1. So if we multiply these, you get 40. Divide that by 80, a is equal to 2. So your answer to this one would be f of x equals 2 times x plus 3, and then x minus 4. And if you wanted to FOIL that out, you could, or just leave it like that. Next page. For 29, your zeros are 2 plus I and 2 minus I, so you're going to write x minus 2 plus I and x minus 2 minus I. Now, if you leave it like that, that's in factored form as a list of products. Or what you could do is distribute the negative, so you have x minus 2 minus I and x minus 2 plus I. And if you redistribute the parentheses here and you FOIL, you get x minus 2 quantity squared. The next 2 will cancel, and then you get minus I squared. This is going to be x squared, minus 4x plus 4, and then that's a plus 1. So x squared minus 4x plus 5. So this is the polynomial, but if they want it in linear factors, you can leave it just like this. So these are 2 good answers. On 31, if your zeros are 2 and 2 plus I, you're going to write x minus 2 and x minus 2 plus I and x minus 2 minus I, because these come in pairs. So if you were to FOIL these 2 out, and then FOIL that, you'll get a different answer, but we're just going to leave our answer like this for now. And this one, degree of 2, you're going to have x minus 1 plus 2I and x minus 1 minus 2I. Let's FOIL this one out. X minus 1 minus 2I, x minus 1 plus 2I. Redistribute these parentheses. This times this is going to be x squared minus 2x plus 1, and these 2 multiplied is going to be plus 4, and x squared minus 2x plus 5 would be in standard form. The next one, this one has a degree of 4, and my zeros are here and here and at 4. So for this one, you're going to have to square that 0, because these are going to give you 2, and that if you only put a 1 here, then your degree of the problem would be only a 3. So it'd be x minus 3 plus I and x minus 3 minus I. And because it would get crazy to factor this whole thing out, you'd have to factor this and then FOIL that, and we're just gonna leave it like that. That's a good enough answer. Number 39, it says degree is 6. And my zeros, we have a 0 of 0, and that has a multiplicity of 3. So they're saying that 0 is a 0, and it has a multiplicity of 3. And we have a 3, so it's x minus 3 is a 0. 3 is a 0, so x minus 3. And 1 plus I, so x minus 1 plus I, and 1 minus I. X minus 1 minus I. So let's count. We want a degree of 6, so 3, 4, 5, and 6, and we're done. For 41, this one gives you 1 plus I, and it's a degree of 2, so you have x minus 1 plus I, and x minus 1 minus I, and so we have f of x here. And let's simplify this. F of x equals, we're going to distribute the negative, x minus 1 minus I, and x minus 1 plus I. I'm going to redistribute these parentheses, so when I FOIL, I get x minus 1 quantity squared, which is x squared minus 2x plus 1. And then I'm going to add 1 because negative I times I is I squared, which is 1. So if I add these up, x squared minus 2x plus 2. Now, normally I have an a value in front. So what I'm going to do is incorporate x is 0. So I'm going to put a 0 here and a 6 for my y. So 6 is equal, I need to find the a value. So if I plug 0 here, 0 squared minus 2 times 0 plus 2. These are going to cross out to nothing. You have 2a equals 6, so a is 3. So a is 3. So now all I need to do is plug a 3 right here, and I have 3 times x squared minus 2x plus 2. So y equals 3 times, and you can distribute the 3. So 3x squared minus 6x plus 6. That's your answer. For 43, I have 3 zeros, and I is one of them, and so is 1. So if I is one of them, so is negative I. And so is 1, so x minus 1. Well, when I FOIL these two out, I get x squared plus 1. And now I have x minus 1. So I'm going to FOIL this. I get x cubed, and then plus 1x minus x squared minus 1, or if I write it in standard form. And now, x is going to be negative 1, so I have an a value in front. And I need my y value is 8. So 8 is equal to a times, we're going to cube negative 1, so negative 1 cubed, which is negative 1, minus negative 1 squared. The 1 and the negative 1, I'm sorry, this is going to be 1x, and then minus 1. So plus 1 times negative 1, and then minus 1. So let's see what we have here. We want to figure out what a is. So you have negative 1 here. This is going to give you a 1, but you have a minus 1. So these are going to, this is going to give you negative 2. This is going to give you a negative 1 minus 1. So what is a equal to? Well, according to this, let's make sure our math is right. We have negative 1 minus 1 minus 1 minus 1. So that's negative 4. So negative 4a is equal to 8. So a is equal to negative 2. So if a is equal to negative 2, you're going to put a negative 2 right here. So negative 2 times x cubed minus x squared plus x minus 1. And you can distribute the negative. So it's negative 2x cubed. plus 2x squared minus 2x and then plus 2. And put your f of x in front. That's equal to f of x. Number 49. They give you 1, 0, and they want you to find the rest of them. So they're giving you a hint. If 3 is a 0, you can write this as x minus 3. So I can use synthetic division to figure out the rest of the polynomial if I take the 3 out. So using the 3 would go outside, and this is x to the third power, so 1 minus 2 minus 2, and then minus 3. So bring down the 1. 3 times 1 is 3. Add, multiply, add, multiply, and you get your 0. So what's left here is x squared plus 1x plus 1. Now to find these two zeros, I would use the quadratic formula. So it's negative b, negative 1 plus or minus 1 squared minus 4 times 1, all over 2 times 1. So it's negative 1 plus or minus square root of 3I over 2. So these are the other two zeros. So 3 is one of them, and the other two, which are imaginary, are negative 1 plus and minus root 3I over 2. For 51, if I is a 0, so is negative I. So you can write x minus I and x plus I. So this is going to be x squared plus 1. So that means this goes into this evenly. So you're going to use long division, x squared plus 1, and you're going to divide x to the fourth plus 3x cubed plus 3x squared minus 3x plus 2. X squared times what is x to the fourth? It would be x squared. X squared times x squared is x to the fourth. We have, and then plus 1x squared. So when you subtract, you get 3x cubed plus 2x squared minus 3x. You're subtracting this, you get 2x squared, and bring down negative 3x. So now we need a 3x. 3x times x squared is 3x cubed, and then plus 3x. Okay, so when you subtract, these cancel, you have 2x squared. This is going to be, 3x times 1 is 3x. When you subtract, you get negative 6x, and then plus 2. And now you're going to add, we have an error somewhere, plus 3x, 3x squared. This is supposed to be a plus 3x, that's why, right here, I copied that wrong. That should be a plus 3x. These are going to cancel, you have no x here, bring down the 2. Now multiply, you get 2 here. 2 times x squared is 2x squared plus 2, and when you subtract, you get 0. So I accidentally copied that wrong. So now what you have here is a polynomial, and what you would need to do is factor that completely. So how do you factor x squared plus 3x plus 2? It's x plus 2 times x plus 1. So your factors are negative 2 and negative 1. So what are the four? You're going to find 4 zeros. I is one of them, negative I is the other one, negative 2 and negative 1. There's your 4. For 53, you have a 0 at 1, and it goes into it, you have it twice. So what you can do is take this 1 out 2 times to see what's left. So you have a 1, a negative 2, a 5, a negative 8, and a 4. You're going to get a 0 here. 1 times 1 is 1, add, multiply, add, multiply, add, multiply, and you get a 0. So what you have here is x to the third minus x squared plus 4x minus 4. Now take a 1 out of this again. You have 1, negative 1, 4, and negative 4. Bring down the 1. 1 times 1 is 1. You're going to add. Multiply, add, multiply, you get another 0. So what's left here? Now this is x squared plus 4. So now you're gonna find the other two zeros, because the multiplicity of 1 was twice, it happened 2 times. So now how do you find these two answers? You're gonna set x squared plus 4 equal to 0, subtract 4, and square root. Your other two answers are plus or minus 2i. And for this one, if 2 minus I is a 0, so is, if x, we have x minus 2 minus I, we now have x minus 2 plus I. So what we're going to do is distribute the negative x minus 2 plus I and x minus 2 minus I. So I'm going to redistribute these parentheses and FOIL. These two, you're going to get x squared minus 4x plus 4, and then these two are going to give you a plus 1. So x squared minus 4x plus 5, this will go into this evenly. We're going to have to use long division. So you're going to take x squared minus 4x plus 5 goes into x to the 4th minus 4x cubed plus 6x squared minus 4x plus 5. You will get 0 remainder, and then what's left you're going to factor to find the other two zeros. So let's get rid of x to the 4th, x squared. X squared times these three are x to the 4th minus 4x cubed, and then plus 5x squared. You're going to subtract, these cancel, these will cancel, and you get x squared. Bring down minus 4x. Okay? And you're probably going to have to bring this down also, because what we have here, x squared, if we multiply this by 1, this times all this is going to give you your 0 remainder. So x squared plus 1 is left over. You have x squared plus 1 when you do long division. And now how do you find these two zeros? Set this equal to 0, and you get plus or minus I. So the four zeros are 2 minus I, 2 plus I, and negative I. And we are done with our assignment.